Hello, this is Chu, and this is my video for Unit 3 Mid-Unit Assignment. So, for the very first question, describe what happens to the domain and range of a logarithmic function enter a vertical reflection. Support your explanation with diagrams. So, here is a graph of a logarithmic function with an equation y is equal to log x. So when x is equal to 1, y is equal to 0, and when x is equal to 2, y is equal to 0.3, when x is equal to 3, y is equal to 0.5, and when x is equal to 4, y is equal to 0.6, etc. So I drew this graph for the parent function, and remember these are the approximate values. So now these values are plotted and drew in a graph. As you can see, the domain of this function is x belongs to R such that x greater than 0, and the range is y belongs to R. So now we are going to move on to the vertical reflection of this graph across x-axis. So the equation of the vertical reflection would be g of x equal to minus log x, and the graph for this equation is drawn here, and you can notice that this is a reflection on the x-axis, and note that the domain and the range remains the same, and domain is still x belongs to R such that x greater than 0, and the range is still y belongs to R. So there is no changes in the domain and the range. And so for this, however, f of x is a function with an increasing interval, whereas g of x is a function with decreasing interval. As you can see, this is increasing and this is decreasing. Yes, this is for number 1. And for number 2, describe what happens to the domain and range of a logarithmic function enter both a horizontal and a vertical translation, and support your explanation with diagrams. So for the parent graph, we have y is equal to log x, and this is a graph of a logarithmic function with an equation y is equal to log x. As you can see, the domain of this function is x belongs to R such that x greater than 0, and range with y belongs to R. Now we are going to transform this graph enter both horizontal and vertical translation. So the equation of the transformed graph would be g of x equal to log x plus d plus c. So here we'll be using an example equation of g of x equal to log x plus 2 minus 3, and this is the graph that has been transformed with the equation. And after the translation, the domain change from x belongs to R such that x greater than 0 to domain x belongs to R such that x greater than minus 2, and the range is the same, y belongs to R. Both of the graphs are increasing intervals, as you can see, but the parent function was transformed 2 units to the left here, 2 units to the left, 1, 2, 2 units to the left, and move 3 units down, 1, 2, 3 here. Yes, this is for number 2. So let's move on to number 3. The question of number 3 is graph the function f of x equal to 1 minus 2 log x minus 4. So we will first draw the the graph here, and we will draw the given function. This is the function for f is equal to 1 minus 2 log x minus 4, as you can see. So for number A, graph the line y equal to x on the same grid. And so we will draw y equal to x line here. This is for number A. And for number B, graph the inverse function f of x by reflecting f of x in the same line, y equal to x. So we are going to reflect this graph under this y is equal to x line. So across this line, so here is the f inverse of x drawn. And for number C, determine the domain range and the equation of the asymptote of f inverse of x. So the domain for f inverse of x is x belongs to R, and the range is x belongs to R such that y greater than 0. So the domain of f of x becomes the range, and the range of f of x becomes the domain of f inverse of x. And it has a horizontal asymptote at y equal to 0 here, as you can see. So for number D, determine equation for f inverse of x. So to solve this, to get the equation, first we will let y to be f inverse of x. So if we move the inverse to the other side, x will be f of y. So we will substitute y in the equation f of x. So x will be x is equal to half log y minus 4. And we'll move 4 to the other side, so x plus 4 is equal to half log y. And we will move this half to the other side, so it will be 2x plus 8 and log y. So finally, we will move y to the other side, so y will be 10 power 2x plus 8, and we will get the 2. So y is equal to 10 power 2 into 4 plus x. So we already got the answer for f inverse of x, since y is equal to f inverse of x. So f inverse of x is 10 power 2 into x plus 4. This is the equation for f inverse of x. That's it for my Unit 3 mid-unit assignment. Thank you for watching.